Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 2-2, dealing with prime factorization. Our objective is to find multiples and factors and also to use prime factorization. We do have quite a few definitions that we need to go over, or a lot of vocabulary terminology here, so you want to be sure that not only that you get these down, but that you review them and understand them. Please bring any questions into class that you might have. I'm also going to put a note at the top here for you to review your divisibility rules. And these are on page 73 in the textbook. Again, we will go over these in class, but if you'll review it ahead of time, you'll be that much ahead of the game. Okay. All right, so first off, we want to start with multiple. A multiple of a number is the product of that number and any non-zero whole number. Okay, so for example, if I wanted multiples of 5, okay, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. So the multiples of 5 would be 5, 10, 15, and so on. Okay, the least common multiple, commonly known as LCM, all right, of 2 or more numbers is the least multiple that is common to all the numbers. Okay, so for example, if I think of the multiples of 5, 5, 10, 15, and so on, and the multiples of 10, 10, 20, 30, and so on, the least common multiple of 5 and 10 would be 10. Because 10 is the smallest number that I can divide by 5, and I can also divide by 10. A factor is a whole number that divides another whole number with a remainder of 0. Or you might say with no remainder. But anyway, okay? So if I wanted to, let's say I was looking at the number 30. 6 is a factor of 30 because 6 divides evenly into 30 without a remainder. 6 times 5 is 30. 2 is also a factor of 30 because 30 divided by 2 is 15. There is no remainder. Okay. All right, a composite number is a whole number that has more than two factors. Okay, so here would be an example of a composite number. The number 4 is composite because its factors are 1, 2, and 4. 1 times 4 is 4, 2 times 2 is 4. So it actually has 3 distinct factors, 1, 2, and 4. So that makes it composite. So it has to have at least, well, it has to have more than 2 factors, or another way of thinking about it is at least 3 factors. A prime number is a whole number with exactly 2 factors. 1 and itself. Okay, it's also, you might want to jot down a note to yourself that the number 1 is neither prime nor composite. Okay, it only has one factor, so it doesn't fit either of the two definitions. So you might want to jot that down on the side somewhere to yourself as an extra note. Prime factorization is writing a composite number as the product of its prime factors. Okay, and usually for this we're going to use the factor tree, so you might want to write factor tree here in parentheses so that if you look at this and you know, what is she talking about? That's generally how we do that. And finally, our last term here is greatest common factor, often called GCF, of two or more numbers is the greatest number that is a factor of all the numbers. Okay, so let's say I would take the numbers 8 and 24. The greatest common factor of 8 and 24 is actually 8, because 1 times 8 is 8 and 8 times 3 is 24. So in that case, those two numbers, one of those two numbers is in fact the greatest common factor of those numbers. That's not always the case though. For example, if I took the numbers 15 and 20, the greatest common factor of 15 and 20 is 5. Each of those is divisible by 5, but nothing larger that goes into both of them. Okay. All right, so that was your list of words, terms you need to know. All right, let's look at some examples. This is finding the least common multiple. Dan goes to the health club every 4 days. His sister Nisa goes there every 6 days. Dan and Nisa both went to the health club today. When will they both go there on the same day again? So here is a least common multiple question. So we want to know on what day they'll both be at the health club again. So what I want to do is I want to list the multiples of 4. So they've started them out for you: 4, 8, 12, 16, 20, and you list a few. Multiples of 6, 6, 12, 18, 24. Okay, actually I can stop at 12. The least common multiple of 4 and 6 is 12, and some people like to circle them so they see them. So both will go to the health club again in 12 days. So basically you're counting forward. This is so you wouldn't have to make out a calendar to see how many days ahead. If you could find the least common multiple, then you could answer the question as to when they would be at the health club again. All right, now we see some quick check questions here. As always, you may pause and do those now, or you can come back to them after you're finished taking notes and complete them all at one time. I'm going to move on to question number 2. Prime numbers and composite numbers. Determine whether each number is prime or composite. Okay, so if I look at the number 17, its factors are 1 and 17. So 17 is a prime number. Nothing else divides into 17. Now if I look at the number 22, its factors are 1 and 22. Notice how I'm kind of making the list here as well. 2 and 11. And then 3 doesn't work, 4 doesn't work, 5, 6, 7, 8, 9, 10, back to 11. Once I would start repeating, I'm done. Because 22 has more than 2 factors, it qualifies as a composite number. Okay, so that's the difference between prime and composite. All right, number 3. Writing prime factorization. Use a factor tree to write the prime factorization of 90. This is one of several trees that could work, but we'll work with what the authors gave to us. So write 90 as the product of any of its two factors. Here they've started with 2, so 2 times 45 is 90. 2 is circled because it's prime. I'm going to keep breaking down 45 until I have nothing left but prime numbers. So 45, 5 times 9 is 45. Okay, so 5 gets circled, and I continue. 9 can be broken down into 3 times 3. Okay, and then I also want to circle that as well because that last 3 is in fact a prime factor as well. So the prime factorization of 90 is 2 times 3 times 3 times 5. Generally want to write these in order from least to greatest. We can also write these as 2 times 3 squared, because 3 showed up as a factor twice, times 5. That's 3 squared. You might not be able to see it real well because I've written in the box just a little bit there. Okay, one last example here. Find the greatest common factor of 32 and 48. So it's wanting you to write the prime factorizations. Okay, in the interest of time, I'm going to not do the trees in the notes with you. Certainly, again, I would try to do it by yourself. Be sure that you can get this, but the prime factorization of 32 is 2 to the 5th power. So I'm writing down all of my, all 5 2's. I don't really want to leave it with the exponents. The prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Now what I do is I match up all factors that are common, that are shared. Each set that I circled, I use that value one time. So that's one set of 2's, a second set, a third set, a fourth set. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So the greatest common factor of 32 and 48 is 16. Again, please be sure that you practice doing those factor trees in the interest of time here. I have not written them out. Certainly we can go over them in class, so if you have questions, as always, please bring them in. Finish the quick check questions here, and I look forward to seeing you soon.